Now we get to the tables. If you look in this section, you'll notice that I've provided you with 4 tables. There's the future value of 1, the present value of 1, future value of annuity, and a present value of an annuity. The book, I believe, also provides you with an annuity due table. I tend to work with the 4 tables because a lot of times that one won't be available for the annuity due. Okay, so a few little terms that you need to be aware of before we even get to the tables. You're talking about the future or present value of 1. This refers to a situation where you're dealing with a single sum, 1 payment, 1 receipt. It's like you've got a note payable of $100,000 due in 3 years. That's a single sum. It's not. It's just one thing that's going to happen. An annuity is a stream of equal payments, and there's a lot of assumptions that go into an annuity. The amounts of those payments have to be the same. They call it rents, equal rents. They always have to be an equal amount, so you can't have $4,000 one month and $5,000 the next. It's got to be a stream of equal $5,000 payments or receipts. And the time intervals have to be consistent as well, equal time intervals. Like it has to be 5,000 a month, not 5,000 now and then 5,000 some other time. So it has to be equal time intervals, the quarter, the month, the year. It has to be in equal amounts. So annuity, think stream of equal payments, stream of equal rents. And the interest rate has to maintain, the interest rate has to stay constant over the time involved there. Okay, so an ordinary annuity, the payment or rent is going to happen at the end of each period. So at 12/31, at 1/31, it's at the end of the period. Annuity due, the payment's made the first of the month, the first of the year, the first of whatever. So obviously that's going to have it's going to be earning, an annuity due is going to be earning more interest since it starts sooner. So that complicates things. So you need to know the difference between the future value and present value of 1, future and present value of what they call an ordinary annuity, that's one due at the end of each time period, and an annuity due, which is due at the beginning. Okay, so now let's go back to brief exercise 6.1 and solve the same problem using the tables. Okay, so this is where the person invested $15,000 today. It earns 8% compounded annually, and how much would it grow to in 3 years? So, okay, so we want to figure that out using the tables. So I come up with 4 questions. Do we need to know the present or the future? Well, if you look at this problem, it's saying he has this much today. How much will he have in 3 years? We need to know the future amount. So that means we're going to go to a future table, okay? We will go to the future value table. And then, is it a single sum or an annuity? And in this case, it's one $15,000 amount. So you're dealing with a single sum, and you need to know the future value. So in that case, you would go to the future value of 1 table. So the answer to those first 2 questions gets you to the right table, okay? Then you say, okay, so what are the number of periods? Well, if it's compounded annually, the number of periods in a 3-year loan are going to be 3, okay? And the interest rate, if it's compounded annually, would be 8%. So let's actually go to that table. Let's see, we're looking for the future value of a lump sum, okay? And so this is the table that you'd be looking at, future value for future value, yeah, and so this is the future value of 1. I usually will make the headings a little bit clearer on this, but anyway. So here you're saying what are the, you've gotten to the right table with the first 2 questions. Now we're going to say how many periods in it. Well, n, these are the periods. It's going to be 3 periods. The interest rate is 8%, and so that gets you to a factor of 1.260. Now, your tables may show up 125971. Obviously, your answers are going to be a little different. All I would say is on exams, I will have you provided with tables, and hopefully we can get one answer, but you know, that's kind of hopeful. So anyway, the first two questions get you to the right table. The second two answers get you to, this is the n, and then across to the interest rate. If it were compounded semi-annually, as our problem, as the second part of the problem was, you would have 6 periods altogether, okay? But you would be using 4%. So it would be a little bit different, okay? Because you'd have 6 periods altogether. So your n would equal 6, and you have to take the annual interest rate and cut it in half because you've got 2 periods each year. Okay, so I think probably the best thing to do is going to be to just work through a few problems like this. But I'd encourage you to sort of look at the tables, take one problem and see what happens when you change the interest rate from up and down. See what happens when you change the number of periods, and you get sort of familiar with how the whole time value concept works. Okay.